Right, let's have a look at this. Then we've got to show this equation here satisfies this one. This is a differential equation. So let's get dy dx then. We might be able to find a shortcut method. Let's get dy dx first. Differentiate this, e to the something differentiates to e to the something, multiplied by the something differentiated, plus e to the something differentiates to e to the something, multiplied by that something differentiated, plus, this is a product, u times dv plus v times du. Now this u dv is this differentiated, which is e to the something, and that differentiates to e to the something, multiplied by that something differentiated, which is a 2. So what have we got here? We've got a minus e to the minus x, plus a 2e to the 2x, plus 10x, e to the 2x, plus 5 e to the 2x, isn't it? So that makes that 7. So I'm just going to add that in there. Plus 7 e to the 2x. So that's that one. Now, okay. Let's get the second derivative now. So d2y by dx squared is equal to, differentiate this, e to the something goes to e to the something, multiplied by the something differentiated, which is minus 1, plus 7 lots of e to the something goes to e to the something, multiplied by that something differentiated, which is a 2, plus product u dv, so we're used to this now, plus v times du. So that's what we got there. So let's tidy it up a bit. E to the minus x. 14 and 10 is 24. And then we got 20. 20x e to the 2x. So sub it in and see what we get then, shall we? Because we've got everything now. So, one of these, that's that. Okay, one of those, minus one of those, so it's minus all this. So I'm going to run the minus and write it down in one fell swoop. So minus this is plus, minus this is, and minus this. So that was that one. Minus 2y, so I got to be careful again. Minus 2 lots of y, which is this. So 2 of these, 2 of these, and 2 of these. So minus 2 of those, minus 2e to the minus 2x, I think it was, minus 2 of the next term, e to the 2x, and then minus 2 of these, which is minus 10x, e to the 2x. So let's see what we've got then. We've got an e to the x there, and an e to the minus x there. Okay, we've got a 20x e to the 2x there, minus 10x e to the 2x, and minus another 10. They go. What's the answer? The answer is just 15e to the 2x. So this and this is the only problems here. Oh, we got minus 2 of them. We got that one, and that one makes 2 of them. Take away 2 of them. So we're simply left with this 24, take 7, take 2 is take 9, 24 take 9 is 15 lots of e to the 2x, which is what we wanted to show. Here's the next part of the problem then. Let's have a look at this. So we need d2y and we need y. We've got y, so let's get dy dx, but we don't need dy dx. But we will need the second. Cos goes to minus sine, so cos of something goes to minus sine of something, multiplied by the something differentiated, so that's a 4. And then the sine of something goes to cos of something multiplied by that something differentiated. Plus, this is a product, u dv, cos goes to minus sine of the something multiplied by that something differentiated, put it there. That was u dv plus v times du, which is just one lot of that. So that's okay. That was that term. Plus the last term, u times the v, sine goes to cos of something, multiplied by the something differentiated, plus, that was u to v plus v, times du, which is one lot of. So that's dy dx then. Yep. Okay. Now let's get d2y by dx squared then. And see what we get. So d2y by dx squared is equal to sine of something goes to cos of something. Cos of 4x multiplied by the something differentiated, so minus 16a lots of. Okay, this is 4b, so cos of something goes to minus sine of something multiplied by that something differentiated, so that'll be 16d. Okay, that's good. Now there's a minus here, so I'm just going to take that and put it at the front. I took the minus and put it at the front so it's more user friendly. I'm going to get rid of the 1 because one lot of is just the thing itself, and I'll do that here as well. Everything seems okay, so I've differentiated that now. I move on to this, so minus bracket u dv, sine goes to cos, multiplied by the something differentiated, plus v times du, and that's minus 4. So that can be a minus 4 there, can't it? So that was u dv plus v du for that term. So we've done that one, and that one. Now this one, cos of something goes to minus sine of something multiplied by the something differentiated. That's that one done. Next one is here. So we've got u, I'll put it up here if I can, plus u, 4x dv dx, cos goes to minus sine with another 4, isn't it? So that'll be minus 16 sine 4x. So that was u dv, cos goes to minus sine of something times a 4 minus 16x sine x, plus v du, and that's just 4 times the cos 4x. So that's that one. Okay, and plus this one, sine goes to cos and the 4 comes out. Plus another 4 cosine 4x. So I'm going to run this minus through on this line here to see what we've got. We've got minus 16x here. So that minus can come through here and that'll make that a plus. So that'll be a plus, that'll be a minus, and this is 16x here, isn't it? Okay. Hope I remembered correctly. Minus 16x cos 4x. So that's the bracket gone now. So, okay, this is 4 cos 4x and this is 4 cos 4x. So that makes 8. So I'm just going to combine those two, if that's okay, and put 8. Okay, good. So now that's what we've got there. And that was the last term differentiated on that one, wasn't it? So d2y by dx squared plus 16y. So this thing here, plus 16 of these, plus 16 of these. So what will we get? Now, Oh no, it's not 16 of those. It's 16 of y's, isn't it? So let's be a bit more careful than that. Okay, it's this plus 16 y's. So let's write that down. Plus 16 of y's. And y was a cos 4x plus b sine 4x. Okay. Plus x cos 4x plus x sine 4x. Okay. And we're supposed to show that that equals, where is it? 8 cos 4x minus 8 sine 4x. So can you see the minus 16a and the plus 16a will go? The minus 16b and the plus 16b sine 4x's will go. What do we want? We want 8. So we want the x sine x's to go as well. This is minus 4. Oh no, minus 16x cos 4x plus 16x cos 4x, so that'll go. And then we've got minus 16x sine 4x plus 16x sine 4x, so they'll go. So we're left with then, all those have now gone, all these have gone except for 4 sine 4x minus 4 sine 4x here, 8 cos 4x. So we've got an 8 cos 4x, which we wanted, so that's right. So that's equal to 8 cosine 4x. And I got a feeling that should be a minus there. So what was that part of? That was differentiating u dv plus v du. No, that was that one and that one. So it was u dv plus v du. But I didn't run the minus through there, so that should have been a minus because there's v du and that was minus 4. I think that should be a minus v du. The good thing is that comes out at the right answer now, so that is the correct thing to say. And these two become minus 8 sine 4x. So the nice thing is when they say show something, you can always check where you might have made a small error and correct it retrospectively. 8 cos 4x minus 8 sine 4x, yeah, that's what we wanted.